Separation techniques. It's not just about sifting litter, there's so much more you need to know for your Combined Science syllabus. This will be the first chapter in the Combined Science Biochem syllabus. It's all about separation techniques. Pause the video to read the complete list of learning objectives that you're supposed to know for this chapter. We are only gonna cover the ones in the red bracket today, and the next part will be in the following series. So, for separation techniques, we look at separating solid-solid mixture, solid-liquid mixture, and liquid-liquid mixtures that are miscible. Miscible just means that the liquid can dissolve in another liquid. So for solid-solid mixture, we can also use these as guiding points. So you can either use magnet to separate a magnetic material from a non-magnetic one, or if there's no magnetic materials within the mixture, you can think about how to separate it based on whether one is soluble in water or even another solvent or not. So this one is commonly tested in a more challenging question. So first up is your magnetic separation, where we talk about separating sulfur from iron. This is a common example, so make sure you are able to recognize the pictures here. So we can literally just use magnet to hover around the iron filings and separate it out from the sulfur. The other method, which is say a substance is soluble in water, then you can actually dissolve it in water, then filter it, even if it's a solid-solid mixture. So this will require you to think of an additional step, and that's why they accord more marks to these kind of questions. So for example, a salt and sand mixture, obviously you're not going to take out bits and pieces from it. What you can do is put water in the mixture to dissolve the salt, because we know sand does not dissolve in water, but salt does. Okay, once you form a mixture of solid and a solution, we can then filter it. Which brings us to the next point. So for a solid liquid mixture, we can separate it into two types, whether you are trying to separate an insoluble solid from a liquid or a soluble solid from a liquid mixture. So for the first one is actually your filtration, which we'll look at it in greater detail, as well as later on we will look at soluble solid liquid mixture separation. Filtration is basically to separate solid from a solution, especially when the solid is very light and are actually suspended in the solution and not easy to separate it out just by pouring the water away. If let's say the solids are actually really huge, like the marbles in the water here, you can actually just decant the water away, which is just a very atas word for saying pour away. Few keywords for filtration that you need to use extensively when you're talking about it is obviously the apparatus. First, we need to be familiar with filter paper, filter funnel, and a conical flask, as well as the products that will be obtained from the filtration. So, residue and filtrate. Residue is just the insoluble solid that will be collected on top inside the filter paper, whereas filtrate will drip down into the conical flask. Make sure you answer your question properly when they ask you to describe the filtration process. I always get my students to say that you will obtain the insoluble solid as the residue. Use the terms as the residue and the salt solution as the filtrate in your answer, just to make it more complete and it sounds nicer, and you are also using the keywords. So now that we've seen like how to obtain insoluble solid from a solid liquid mixture, let's look at how we can actually separate soluble solid liquid mixture. If you just want the solid only, and you don't really want the solvent, then you can just use evaporation to dryness or crystallization. And again, for these two processes, they are kind of similar, and that's why you also need to be able to distinguish which one is a more suitable method to use compared to the other. But if you want both the solid and the liquid, then you will need to use a more complicated setup, which is for simple distillation. So I'll just have you a Venn diagram, right? The differences between evaporation, dryness, and crystallization. Make sure you star this page or even make some notes on it, because it's really good compilation of the differences between both processes. So in both processes, they require heating, but only evaporation to dryness will require heating all the way to the end. Okay, and these are evaporation and dryness will be suitable for compounds that are stable to strong heating, meaning that they don't decompose when you heat them for too long. However, most compounds are actually susceptible to strong heating, meaning to say they decompose when you heat them for too long, and they will change into a different element or a structure or something else totally, which is not what you want. You simply just want to separate out the substance and not change them. So for those kind of compounds, you will use crystallization instead, where you heat until a saturated solution forms, then you leave it to cool and crystallize. Okay, so those are some keywords that you will be required to use in your description. So evaporation to dryness will be strong heating until all the water is driven off, and crystallization, the terms cool and crystallize. But both processes will result in obtaining the dry solid from the mixture, but you won't get back the liquid portion. If you want the liquid portion, then let's do simple distillation, where you will have a more complicated setup such as this, with a Liebig condenser, a thermometer to measure the boiling point and to make sure that it is actually fixed at that temperature. So what happens is during simple distillation, the solid will be left behind in the original flask, while the liquid portion will distill over to the distillation flask. Now let's come to the last part where we talk about liquid-liquid miscible mixture. And for this method, to separate this mixture, we usually just use fractional distillation. You might see that they are actually kind of similar to your simple distillation, with the extra portion of a fractionating column over here. So fractional distillation is actually to separate miscible liquids that have very similar boiling points. For example, ethanol and water, which only differs like 22 degrees Celsius in their boiling point. And the addition of the fractionating column actually helps to increase surface area for the vapor of the higher boiling point to condense, and then the droplets will then fall back down into the flask this way. Whereas for the other liquid that has the lower boiling point, right, even if it travels a far distance up to the top here, it is still too hot for it to be able to cool and condense. So instead, it will pass into the condenser and then move through it and condense into liquid before dropping back down into the distillation flask like this. So in this way, we are able to separate out the two liquids even if they have very similar boiling points. Pause the video to try out these questions. So did you get your questions correct? Thank you for tuning in, and I'll see you next week. Bye!